What do you mean by recovery techniques? Say if I am executing a transaction. If I execute a transaction can contain a number of steps. While executing these steps, if I fail, my transaction fails here. Then what should be the course of action? I should be able to roll back to a previous stable state of the database. It's not only rolling back, sometimes you have to also roll forward to establish a consistent state. So we'll be looking at what happens when a failure occurs and how should we roll back or roll forward. So we are looking at another term, roll forward here. Okay. So we'll be looking at these things today. So we're going to consider this particular table, the account table, and we'll have some values for these three accounts A, B and C. And for this kind of a table, say if there is a query that should be executed on the table such that the value in A should be subtracted by 100. So I'm just doing a minus 100 for the balance in account A. So if I'm going to run this, this itself is a transaction, right? I'm going to run this as one unit of work on the database. So after this, I should commit. So if I am going to run this, what are the steps that happen in the background? So we'll take a look at this. So when you talk about a database, you have this hard disk. So you consider this to be the hard disk. And on the hard disk, you have a set of files corresponding to your database management system. And these files are data files. And we have another set of files called the redo log files. So what the data files hold, it holds all your user data. Say your table data is residing in your data files on the hard disk. Whereas on the redo log files, you'll have a set of data that will be used for recovering our database. So there are other set of files like control files, which will hold where the data is and who are the users who can access the data. Such kind of control information will be there in your control files. So when you talk about a database management system, your data is maintained in a set of files on the hard disk. When you run your database management system, that's when an instance gets created. What do you mean by running the database management system? Say you open your laptop, you run the service, and then you get your database management system software up and running. So in that case, you're going to have a database instance created. What is a database instance? It's nothing but a set of shared memory instances and a set of processes. So when you're going to run a database management system in your laptops, you'll have a database instance getting created. So what Oracle is going to do is, it's going to go and acquire some memory for running its software. So it's going to have a set of shared memory architectures. So what are those shared memory architectures? You call that to be system global area. So you'll have this buffer cache and redo cache. You also have other types of caches like log cache, dictionary cache, but we'll be focusing only on these two caches. And you have a set of processes also getting loaded. That is the DB writer process, log writer process, and you also have a checkpoint process and a server process. So this Oracle instance is for one particular database management system that's running in your laptops. And you also have a listener. What do you mean by a listener? A listener will be waiting for requests, listening to requests from your clients. So how you connect to your database management system software? You use an application to connect to your database management system software. You would have written some PHP code. From that PHP code, you'll be issuing some calls to your DBMS. How will you establish a connection to your database management system? What all things you will do? You will give the port number, you will give your user ID and password, and then you will give the server ID to which you are going to connect to. So the listener by default will be listening to this particular port number 1521. Okay. So we have this listener which is listening in the default port number 1521, and you want to know the details of the port number, service ID for your systems. Where will you go and look at it? You have to go and check the tns names.ora file. So you have to go to your Oracle installation folder, and then you have to search for this file, tns names.ora file. So this will have all the details of on which host your system is, your database instance is running. It will also give you the port number, the service ID. So you have to use these parameters while you're establishing a connection with your database from your application code. So you can go and verify these details from this particular file for establishing a connection. So once when a database instance is created, the listener is waiting for request from the client. Say as a client, I am connecting to my database using one of the application servers I have, and I establish a connection using that connection parameter. I give user ID, password, port number, and the host to which I'm going to connect, and then I establish a connection first. So once when a connection is established with the instance, what happens is this listener spawns a process, creates a process for that particular application that's connecting. So for every user or for every application that's connecting to your database instance, you'll have a server process getting created. This process will then execute all the queries given by this particular application. From then on, if this user executes a query, this query will be given to whom? The server process will be taking care of that. It will not be in sync with the listener anymore. The listener will be taking care of other requests that are coming in. So the server process is responsible for all these things. That is scanning all the keywords in your SQL query and then parsing, checking whether the syntax is correct for your query, and then optimization of your query. So for this, it will be using all the dictionary files in your cache to check whether the table exists in your database or whether that query that you have written is correct, what kind of blocks you should fetch from the hard disk for executing that query. So optimization, everything will be taken care of by this server process. So once when all the validation and optimization is done, the server process will execute so that it brings the blocks, required blocks from the hard disk to your buffer cache. So buffer cache is where the blocks that are in your hard disk will be moved and will be used for manipulation. You cannot directly go and sort the records in your hard disk. Hard disk is just for storage. Whatever happens in your main memory. So that's why we were focused on bringing only the blocks required to our main memory so that our intermediate relation here gets reduced and our query executes much faster. So you understood why we use buffer cache. So from then on, if you want to execute this query, update account and make changes to the account, what will happen? The changes will be happening here. It will be happening in the buffer. So a transaction has a series of steps that will execute here in the buffer, right? And while it's failing, say if it fails here, a transaction can fail while it is executing the steps in the buffer. So any kind of failure can occur. Say you made 4 changes to this data on the buffer, and then the 5th change you failed. So how to recover from a failure? That is the question here. And we have to understand certain terminologies here: system, global area, and Oracle instance. This documentation that I'm showing here is from oracledocs.com. So I've taken it from there. So what is the system global area? The system global area is nothing but a group of shared memory structures that contain data and control information for one Oracle database instance. And this is one more thing. Multiple users can connect to the same database instance. Say I create many users for my database I am running, right? So I can have Sam, Ram, Tom, all of them accessing the same database instance. So in that case, everybody will be sharing this buffer cache. Every user will be sharing this buffer cache. So some user wants some other part of the hard disk to be moved to this place. It will be done for them. So every user will be sharing that buffer cache and the redo cache. So they will be sharing this system global area. Every user will be sharing this system global area, otherwise called shared global area. So, and what is an Oracle instance? It's nothing but a set of memory, shared memory structures like buffered cache and redo cache, along with processes like log writer and database writer. We'll see what these processes are in the coming slides. So, how this memory allocation happens? Oracle automatically allocates memory for a system global area. So, if you're going to run Oracle DBMS, automatically the instance when it's getting created, memory gets allocated for all these things. So I was talking to you about failures, right? What kind of failures can occur while a user is executing his transaction? So from the application server, you're executing a transaction on the database. What kind of failures can occur? A network error can happen, right? You are connecting to the DB server from your application server over a network. So there can be a network error. So after executing 4 steps, the network connection can be down. Or else a system crash can happen, and hardware, software, or network error can happen. Transaction error, this is very important. See, I am trying to write a balance which is actually greater than the size of the balance given in the database. See, I am trying to write a balance which is of size 15, whereas the size for the balance in the database is only 10. So there will be an overflow happening. So you will get an exception happening, and a division by 0. The pace of my transaction, I'm trying to divide something by 0, so definitely an exception will terminate the transaction. Exceptions detected by the transaction. What is this? There is one good example here. Insufficient balance and hence cancellation of withdrawal. You're trying to purchase something, but your balance is insufficient. So in that case, definitely the transaction will be cancelled. Concurrency control enforcement. What is this? I was talking to you about deadlock in the last class. When 2 transactions are in a deadlock, automatically one of them will be cancelled and the other one will take up the logs. The cancelled transaction will again restart with the same timestamp. It should restart with the same timestamp. Why it should restart with the same timestamp? So that it will be the older transaction when it comes up again. Okay, so to avoid starvation, we go with restarting a transaction like that. So concurrency control enforcement can also stop a transaction. Okay. Disk failure. Some disk blocks may get corrupted. So part of your blocks that are getting corrupted can lead to a failure. Physical problems like fire, sabotage, floods, everything also will lead to a failure in your systems. So our class today will be focused on how our database recovers from these failures, how we move this database to a consistent state when a failure occurs. What is that's happening internally? Say there are certain things that are beyond recovery. For instance, you stored the entire database on one server in one place. One good student went and set fire to that server. Definitely, there's no way to recover that. But if you have a backup and replication process wherein you have the server, automatically the replication will be happening to some other server in some other location on the globe. Though you set fire to this, that server will be taking up and answering all your queries. So that kind of replication mechanisms, you want to learn, you can go and look at my videos on advanced database management systems for replication. But anyway, we will not focus to that level. We'll be only focusing on some of the minor problems that can occur as failures. So let's take an example here. Say let's consider this account table, and let's say user Satish wants to transfer 100 rupees from A to B. So what are the steps he has to perform? He has to begin transaction, write log A, read balance of A minus 100, write balance of A, write log B, read balance of B plus 100, write balance of B. A simple transfer of 100 rupees from A to B, done by one particular user. So you call this entire thing as a transaction. So now let us take a look at this thing. Say I have done 1, 2, 3, 4. I subtracted 100 rupees from account A. Then the transaction fails at this point. Maybe a network error happened or some kind of overflow happened. So what are the steps I will not be able to execute? I will not be able to execute these steps because I have crashed or some kind of failure happened. So what should be the recovery thing here? I have subtracted 100 rupees. Say if your account has 400 rupees, I subtracted 100 rupees. So A is now 300 rupees. And I failed without adding 100 rupees to account B. So what should be the recovery process here? From 300, I should roll back to 400. Only then it goes to the stable state, some state that was existing before the transaction started. So that kind of a state we have to go to. So what we have to do? Rollback should happen. Changes should be rolled back. That is necessary. So we have seen a demo on rollback, right? How rollback happens? I just show you for those who are absent. Say if I have this select star from account, so we're just going to see how rollback happens here. So I'll update 8 from 400 to 300. How will I update that? Update account, set balance is equal to balance minus 100, where ID is equal to A. What is there in the table now? Select star from account. So 300, say if I fail after this, I should somehow roll back. How that rollback should happen? We have a command, rollback. So if I say rollback, it says rollback complete. We'll go and see select star from count. So you see here, earlier it was 300, now we have rolled it back to 400. So that's why I tell you in your labs, commit before you move to the next change. Why I say commit? Once when you commit, you will not be able to roll back. Commit is like you're moving the changes to the database. But once when you don't commit, everything will be in the buffer, and when your transaction fails, or when your instance fails, or when your application has a network issue, so what happens is everything will be rolled back to the previous state. Your changes will not be saved as a permanent change in your database. So that's why commit is very important. So, but then we understand one thing here, right? What is that we understand? Somewhere the database stores the old value 400 and then the new value 300. So, once when I say roll back, it's able to roll it back to the old value. Somewhere it has a process wherein, okay, you're changing this. I will also, as a caution, maintain the old values. So, we have seen a demo for rollback. We'll see how rollback happens internally. Rollback is possible because of the redo log files and by the use of the following techniques. So you have three algorithms that we're going to see: recovery based on deferred update, recovery based on immediate update, and recovery based on shadow paging. So in today's class, maybe we'll look at these two things. In next class, we'll be looking at shadow paging. So we'll see what is recovery based on deferred update. So what this algorithm or technique says is a transaction cannot change the database on the disk until it reaches the commit point. So you have a transaction, a series of steps. There will be no changes on the hard disk until the commit point is reached. A transaction does not reach its commit point until all its update operations are recorded in the log and the log is post written to the disk. I know this is a little difficult to understand. We'll go with the example here. So what we are going to do is we are going to consider this transaction for our example. We'll see how this particular technique deferred update works. So we'll take this transaction and then we'll see how the deferred update works. So for that, we'll start with this example. I'm just going to focus on the cache files alone, the buffer cache and the redo log files. So when I say buffer cache, this particular table that we are working on is retrieved from the hard disk to your cache. So once when it is retrieved, what all the steps we have to run on the cache? First step is we are transferring 100 rupees from A to B. What is the first step we have to do? Reduce 100 from A. So we are reducing. This is the first step. Change value of A to 400. And before changing the value of A, record the before image and after image of A in the redo log file. So what your Oracle internally does is, okay, I'm going to change the value of A by subtracting it by 100. So before subtracting it, this is the before image, that is the old value, and this is AFIM, that is after image 400. So before changing the buffer cache, I'll write it to my redo log file. So you understood this. Before you before the system makes a change in the cache, it's going to have a copy of that in the redo log file. So this kind of logging is called write-ahead logging. So before I make a change, I will log the changes in the redo log file. You call that to be write-ahead logging. And after that, what I should do, I should go and change the value in the buffer cache. See, now it is being changed from 500 to 400. After logging, I'm changing, so I'm calling that to be write-ahead logging. Once when this change has happened, what is the next step in my transaction? I have to add 100 rupees to B. So what is that step 2? Step 2 is nothing but change the value of B to 200. So I have to add 100 here. Before changing anything here, what I will do? I will log it here in the redo log file. The before image of account B is 100, after image is 200. I'll log it. And then what I will do, I will go and change it in the buffer cache. See, now it is going to 200 rupees. What is the final step? After all the steps are done, you go and issue a commit. So when the transaction issues a commit, the very first thing that will be done is the log writer process. There's a process called log writer, LGWR, will first flush the redo log files to the permanent storage on the hard disk. So the redo log file was on the main memory, right? That will be first flushed to your hard disk. Once when that is done, next the database writer process will flush every changed value to your hard disk. So you see in your hard disk what is there until this point in time, that is the old value. So only when commit reaches, it's going to flush, and you see now the database got updated with the new values. So you have these two important files, that the redo log file and data file. From the data file, you move to the buffer cache, you make the changes. For every change, you record it into the redo log file on the memory. Once when it reaches commit, flush it to the database as a persistent storage. So you're going to move all the logs to your database, and then the DB writer will flush all the changes to your data files. So this is happening. So this is a successful transaction. What is deferred update? You are just deferring the updates to the database until commit of a transaction. See, I'm not changing anything in my hard disk until I reach commit in a transaction. You're deferring the updates to the database, so it is called deferred update. This technique is called deferred update. So what all things we have learned here? What is write ahead logging? Before I move any changes to the database or to the buffer, I'll log that change. That is write ahead logging. And what is the log writer process? Moves all the information on the redo log files in the cache to your persistent storage. What is the database writer process? It moves all the changes on the buffer cache to your data files. And what is deferred update? I am deferring the update until the transaction reaches the commit point. So now we have to take a failure scenario. What is this failure scenario? Transaction fails after step 1. What is step 1? I subtracted 100 rupees from account A, so it is now in 400. And then I also logged the change, right? Before even changing it, I have logged it in the redo log file. And after that, some network error has happened or something has happened, so I failed. So in this case, what should be done? Should there be anything changed on the database? You see there, we have not touched the database still because everything is in the redo log file. So there is nothing to do. There's nothing to change, right? Because you didn't, the transaction didn't commit. So there are no changes on the database. So you call that to be an no undo. You're not going to undo anything on the hard disk. Is this clear? What do you mean by no undo? Because there's nothing to undo here. No changes affected our database. We'll take scenario 2. What is scenario 2? I have completed all my transaction. I have returned commit. So what happens is the log writer flushes everything to my hard disk. So the log writer finishes it and then it fails. The database crashes. So what is here in your redo log file? A commit was issued. Everything went on successful. And then what you did? You wrote it to your persistent storage. At this point, your database instance failed. say your laptop due to power shutdown, it shuts down or something happens. So everything is now in your persistent storage on your hard disk. Now again you start your service, you bring your instance back. Now there is something in the redo log file, whereas those changes are not reflected on your database because it failed before the DB writer can write it to your data files. So now how the recovery will happen? The recovery is the transaction has committed, right? So you have this checkpoint process. So you have the checkpoint process. This checkpoint process, what it'll do is when you start up your instance again, it'll go and check whether your redo log files and data files are in sync. So when you take a look at this, the redo log file says these changes should be applied on the data files. So what it will do is, it will go and again redo things because this transaction has committed and it has ended successfully. So what it will do is, it will go and change to 400 and then it will change B to 200. So it will redo things and this is called roll forward. What is this? Roll forward. Because we are not rolling back, we are making the changes, we are rolling forward the changes. So automatically this will happen when you again bring the database instance back, the checkpoint recovery process will go and check the redo log file, compare that with your data files. There is a mismatch, there is a transaction that has already committed, no need to roll it back, just apply these changes to the data files. So this is called roll forward and you call that to be a redo updates on the database using log. You understood what do you mean by redoing updates on the database? After committing, writing the files to the log, I failed. See again one more thing you can see here, when I start my database instance back, the buffer cache and redo log file will be empty. It's memory RAM, right? So I'm just restarting my laptop. So again these things come up, but then the changes will be recorded on the persistent storage, that is your database hard disk. Now do you understand why we are flushing the redo log file first before writing it to the data file? That is the concept. So this algorithm comes under this technique called deferred update. What do you mean by deferred update? Until commit, I'm going to postpone the updates happening on my database. And this technique under deferred update is called, what is that? No undo redo. What is this technique called? No undo. Why it is no undo? Nothing to undo when a transaction fails because we will not change it until it commits. What is redo? If it fails after commit, we'll redo the changes from the log file to the data file. So we'll take a look at one more technique, recovery based on immediate update. So this is another technique used in database management systems. What immediate update means is, I will not wait till commit. Whatever changes I do to the buffer cache, immediately I will move it to my database. That is immediate update. Whatever it is, the update should be logged in the redo log file. Whether it is immediate update or deferred update, I will log it in the redo log file before making changes. So we'll take a look at how this thing works. We'll take the same scenarios again. We'll have this in the buffer cache and the redo log file is empty. So we'll see how an immediate update works. So what is the step one? I have to subtract 100 rupees from account A. That is my transaction. So I'll go and subtract 100 rupees. Before that, I will log the before image 500 rupees and after image 400 rupees. And then I'll go and change it. You see here, now it changes to 400. After changing it, what I should do, this is immediate update. So what I will do is, I will immediately use the log writer process, run it and move it to my redo log file. Because immediately I will flush the updates. Once when this is written, next thing what I am going to do, this change 400 using the DB writer process, immediately I will update it to the database. So it is now changing it to 400. So any updates that happen in my transaction immediately gets flushed to my database. What is the next change that should come in? This approach is also called force approach. They use a keyword force approach, that is writing updates immediately to the disk. I am force flushing the data from the buffers to the data files. So what is the next step? That is you go and log the changes that you will do to B. What is that? Before image is 100, after image is 200. And then what's the next step you have to do? The log writer will log this immediately, and then the DB writer will log the changes as 200 immediately. Finally, commit will happen. This is another technique. So now we'll talk about the failures. What kind of failures can happen after you transaction one, after it fails subtracting 100 rupees from A. So what we'll do is we'll think about the failures here. Say before changing A, what I should do? I should log it here, and I will go and change A to 400. So it is getting changed to 400. Next, what I should do? I should move this to the persistent storage. So after this, my transaction fails. So you consider 400 also is written to this particular data file. So after this, my transaction fails. I made only one change to A, and then my transaction fails. Now what should be the process of recovery? Should we undo anything from the hard disk? Should we undo anything from the hard disk? What we should undo? 400 should be changed to 500. So now our database instance crashes, right? So what we can do is we have to undo changes on the database. Now our checkpoint recovery process comes into picture, and this process verifies these two files, and it finds that there is something that should be undone because this is not committed. There is a commit here? No. There is no commit issued here, so it will undo all those things that were not committed from the data files. So what this checkpoint process will do, it will go and change 400 to 500 on your data files in the hard disk. So this is called undo. Why we have to undo? Because we have made some changes that we have not committed. You understood this entire process. What is immediate update? I make every changes. I log those changes immediately. I will also write those changes immediately here. But once when I fail at a certain point in time, the checkpoint recovery process will check, say there is no commit issued for this transaction. So whatever that is not, say there is no commit here, so everything here should be, there should be an undo of everything here. So it will go and verify all the mismatches here, and it will start performing this. So it will just restore the before image 500 here. So this is called immediate update and undo. Failure scenario 2. What is this failure scenario 2? Say you're going to make the changes to your database, and then you're also going to go and log it. So first change is done. So it writes it to the persistent storage. So it's 400 now. So this will also be written to your data file. So that is also updated. The next change is it will change it to 100 to 200, right? So it will log it here. B is changed. B is written to your persistent storage, and then the data file should be logged now. All the redo log files is getting logged here. So you'll do a commit, right? You issue a commit, and then you log everything here. After this stage, you fail. The checkpoint process, what it will do when you again restart your service, it will go and verify, okay, there a transaction is committed, but the changes have not been applied on the data file. So it will start to redo everything on this thing. So until this commit point is reached. So when it redoes things, this will be 400 and this will be 200. Now you have reached the consistent state of the database. So when you start the instance again, a redo will happen. Because why it does a redo? In the redo log file, there was a commit present for a transaction that is completed earlier. Once when you commit a transaction, you can never roll it back because it will go and apply the changes to the data disk. You can very well see this here too. Say if I commit a transaction, say I'll update this, update the balance is equal to update account, set balance is equal to balance minus 100, where ID is equal to A. So now these changes will be in my buffer cache, and the redo log entry will also be logged here. So this is done. Now what will be the value in my table? Select star from account. It will be 300 because I subtracted 100. But when I issue a commit, I consider changes to be permanent because it is entered into my redo log file. The commit has been issued. Now can I roll back? So it says rollback complete. So you say select star from account. So it's only 300. You cannot roll it back to 400 because you have issued a commit. So that's why we say one of the properties of transaction is commit. That means it's permanent and you can never change it. And that's what is even applied internally inside a database management system. So what we have looked at here is today is two algorithms or two techniques, deferred update and immediate update. Under deferred update, we looked at this particular technique, and it's no undo and redo. Whereas under immediate update, we looked at this particular technique called undo and redo. Okay.